Welcome back. Let us solve a couple of more questions on differential equations. Uh, Next example says that show that sine y is equal to x is a solution of the given differential equation, which is dy by dx is equal to 1 over 1 minus x square under root. And it is given that y is equal to 0 when x is 0. So basically it says that the original function is sine y is equal to x, whose differential equation is dy by dx equal to whatever is the function 1 upon 1 minus x square root, right? In order to prove this, there are two types of, or you can say there can be two approaches. One is, since the original function is given to you, which is sine y is equal to x, and we have to show that the differential equation that you will form using this function should be dy by dx equal to this, right? For that, what we can do is we can differentiate this sine y is equal to x with respect to x, obviously, right? So if sine y is given as x, I can differentiate this with respect to x. So for this, we will first apply the chain rule. So we will first differentiate this sine y with respect to y, which is cos y, and then differentiate y with respect to x, which is dy over dx, and derivative of x is just 1. That means dy over dx must be 1 over cos y, right? And from here, since we have to prove or write the final answer in terms of x, so we have to express cos y in terms of x if sine y is equal to x, right? So we have a triangle, right angle triangle. This is how we can write sine y in terms of cos y, or if sine y is x, so what will be the value of cos y? It is just like using the identity sine square x is equal to 1 minus cos square x. Okay, so if this sine y is x, that means it is opposite, and this is hypotenuse. So what will be the base? Okay, so it is 1 minus x square root, right? So value of cos y in this case, if this angle is y, so sine y is x, so cos y will be 1 minus x square root. Okay, so I can replace this cos y as 1 over 1 minus x square. Okay, so that means that the function sine y is equal to x, that is the solution of this differential equation. This is one way to prove this. But you will notice here that we haven't used the given condition that y is equal to 0 when x is 0. It is obvious from the given function that if we put x equal to 0 or y equal to 0, you will get the output x as 0. Okay. But since we are doing differential equations, this is just by understanding that what do you mean by differential equation, that if the original function is given to you, then we can form an equation which involves the derivative as the variable. Okay, there is nothing wrong in this. But since we are doing integration or solving the differential equation, that means we have to go back from this dy by dx to sine y is equal to x. Okay, so we have to go basically in this direction, and then also we have to use, or we can use this initial condition that y is equal to 0 when x is 0. These are just given to find out the constant of integration. So let us integrate this with respect to x and y just by separating the variable. Okay, now if you can see that if I separate the variable, I will get dy is equal to dx over 1 minus x square. Okay, and this is basically the integral of sine inverse x, which you haven't learned in your A level, neither in the AS level. So what we can do, just by using our basic knowledge of integration, what we have learned in this class, how we can integrate this, or how we can get the output as which involves their trigonometric functions. You can replace this x. Okay, if sine x is equal to sine y is equal to x, or x is sine y, I can replace this x as sine y. So it is dx over 1 minus sine square y under root. There is nothing wrong in this, that I can replace this x by sine y. Okay, means if this is the solution of this differential equation, that means it must satisfy the differential equation. Okay, so dy is dx over 1 minus sine square y. That means dy is equal to dx over cos y. Now I can transfer this. You just remember that what we have done in the method number 1, that we were going from solution to the differential equation, and this time we are going in reverse. If you are realizing this fact, that now I will transfer this cos y to LHS, so you will get cos y is equal to dy is equal to dx. Okay, separation of variables we have done. Now I can integrate this. Integral of cos y is sine y. This is integral of dx is x plus c, and now these conditions will also have to be used. So since y is equal to 0 and x equal to 0, so value of c is 0. So I will get the differential equation, not the differential equation, but the solution is sin y is equal to x. Okay. So basically we have to use the method of integration, that from the differential equation we should arrive at the solution. Okay, let us solve another question. Using the partial fractions, find this, and then given that y is equal to 1 when x equal to 0, we have to solve this equation. Okay, right, so let us quickly solve this. Partial fraction, let us do this. I know the direct method, that if I put y equal to 0, I will get 4. Y equal to 0, I will get 1 upon 4 as the factor. So it is 1 upon 4y. And then if I get y is equal to 4, again I will get 1 upon 4. 4 minus y. Okay. Yes. Okay. Now I can integrate these. Right. So let us integrate this. This is 1 by 4 ln y plus 1 by 4 ln 4 minus y. And here the coefficient of y is negative, so this will be minus. So 1 by 4 ln y over 4 minus y. This is the solution of this integration. Now it says that also there is, yes, plus c also we have to use as far as part 1 is really concerned. Then it says that given that y is equal to 1 when x equal to 0, we have to solve this equation. So if I have to solve this, so using separation of variables, dy over y into 4 minus y is equal to dx. If I integrate this, so as you can see that my solution will be the solution of the first part. Okay, this is integral of dy over 4 upon 4 minus y. So I will get my solution as y is equal to, not y, I think this is x. Yes, so x is equal to 1 by 4 ln of y over 4 minus y, and plus c we have to find out. It says that when x is equal to 0, y is 1. Okay, that means it is 0, 1 by 4 ln 1 over 4 plus c. Right, that means value of c is just minus of ln 1 upon 4, means it is just ln 4. Okay, ln 1 by 4 can be written as minus 1 by 4 ln 4. Okay, and this 4 can be transferred to LHS. This can assimilate into 0. So you will get C as just ln 4. So putting the C ln 4 back into the equation, it says that x is equal to 1 by 4 ln y by 4 minus y plus ln 4. Right, and also here also you can use the property that log a plus log b is log ab, but before that you have to transfer this 1 by 4 into the exponent of y as 1 by 4. Okay, this is your second part answer. And third says state what happens to the value of y if x becomes very large and positive. Right, here what we have to do is After transferring this or converting this raised to power 1 by 4, then applying log a plus log b. Okay, let us do this. Third part is we have to express the value of y if x becomes very large and positive. So basically we have to express y in terms of x. Okay, so if x is this, now I'm applying the properties of log, that this is 1 by 4 into 4. Okay, log a plus log b is log ab, right? This is x. So here e raised to power x is equal to y over 4 minus y raised to power 1 by 4 into 4. That means e raised to power x by 4 then raised to power 4 is equal to y over 4 minus y. Okay, again you have to transfer this to LHS 4 minus y, then e raised to power x by 4 raised to power 4 and then minus y is equal to 0, right? And then expressing y in terms of x, this will be 4 times e raised to power x by 4 raised to power 4 is equal to y e raised to power x by 4 raised to power 4 plus 1. Right, now it says that when x becomes very large and positive, I can transfer this to in the denominator of this. So this is y is equal to 4 e raised to power x by 4 raised to power 4 upon e raised to power x by 4 raised to power 4 plus 1. Right, so this is your y which is expressed in terms of x. Okay, now here it says that when x becomes very large, what will be the value of y? Okay, that means we have to find out the limit value of this. Okay, if you put x equal to here, you will get e raised to power infinite. That means to say x becomes very large means x is tending towards infinite. Okay, if x tending to infinite, this will be infinite and this will be again infinite. Okay, so I think the finding the limits is not in the syllabus, but since the question is there, I have to divide this by e raised to power x by 4 raised to power 4. So your numerator will become just by 4 and here it will get e raised to power x, not just like this. We have to divide this by e raised to power x by 4 raised to power 4, means from this term I have to divide both the numerator and the denominator. So it will just be 4 in the numerator and in the denominator it will be 1 plus 1 over e raised to power x by 4 raised to power 4. Okay, now if x becomes very large, so this whole quantity will tend to infinite. That means it will be 4 over 1 plus 1 over infinite. That means it is approximately equal to 1 over 1 plus 0. So value here is 4, right? This is how we evaluate the limit of a function if some variable is tending towards either 0 or infinite. Okay, so limiting value here will be 4. So that's all as far as differential equations are concerned. In the next video, I will start with the vectors. So stay tuned to my channel. Just watch other videos also. I think only 2 chapters are remaining as the exams are approaching. We have approximately less than 20 days left for the final exam. So I will try to upload all the videos for the next 2 lessons. Till then, bye bye, take care. Thank you.